Alright, good day, student. As you can see, you are given a problem involving circle geometry. In this case, we are asked to consider the diagram shown and use it to find the area of the inscribed quadrilateral OBAC. And you are asked to leave your result to 2 decimal places. So, let's do as we are required to do. So the first thing you have to do is to solve this type of problem. We have to look at it and be able to consider certain concepts. So from here, we have from sector A or from sector B or A. From sector B or A, from sector B or A. This sector here, BOA, including this arc of length. So from that, we know that the length of an arc, in this case, we have BA is equals to, it is given to be equals to 8. So let's call this angle that is sustained here, angle that is here to be theta. Let's call it to be theta. So this is equals to theta over 360 multiplying 2 pi r. Multiplying what? 2 pi r. So once we have done that, we have to notice that since O is the center of the given circle. Notice that BO is equals to given as 12 cm, and this is the radius of the circle. So all you need to do is to put it here. You have 8 in equal to theta over 360 times 2 pi times what? 12. So from here we can make theta the subject of the formula. So theta from here, cross multiply, have 8 times 360, remember that this is degree, divided by 2 pi times 12. So from here, we can now simplify. We can now do what? Simplify the expression. Can we simplify the expression? Let's go into simplification of the expression. So from here, simplifying it, you have the theta of is equals to 120 degree divided by pi. 120 degree divided by pi. So once we have done that, the next thing you have to do is to consider a triangle BOA. From triangle BOA, we know that BO is equals to AO, and that is the radius of the circle. We call it R. So we can use the ordinary trigonometry formula to find the area. So area of triangle BOA is equals to half. You can take either this or this side, BO squared sine theta. So that is it. This implies since triangle area of triangle BOA is equals to area of triangle B is equal to area of triangle AOC. These are similar triangle. The reason is that triangle BOA is equals to triangle AOC. These are congruent triangles. Congruent triangles. And congruent triangles have the same properties. They have the same properties. So since they are equal, this implies that the area of quadrilateral OBAC is equals to 2 times area of this triangle, 2 times area of triangle BO, 2 times area of triangle BOA. So that is this multiplying BO squared sine what? Sine theta. So multiplying it sine what? Theta. So let's proceed. So area of quadrilateral OBAC is equals to, this can cancel out here to give us what? BO squared sine theta. So all you need to do is to put the values. So what do we have as BO? What do we have as our BO? We have our BO to be equals to 12. So 12 squared. And what do we have as our sine theta or theta? When we solve for we have that theta is equals to 120 degree divided by pi. Remember, when we solve it, I'm finding the length of an arc. So you have to put it here. Half sine 120 degree divided by pi. So solve it. Solve for this. So solving it, you'll be getting, because this is an approximation, you'll be getting 89.0452. And asked to leave your answer to 2 decimal places. So therefore, area of quadrilateral OBAC is equals to 89.05 cm squared to 2 decimal places. So if you enjoy this lesson, will you do me one favor? Subscribe, click the subscribe button, the red button by the right hand side. Just click it to encourage me to bring more videos for your views. Like and share, others will be aware of these free videos I'm giving to you. As well, click the notification button whenever there is new update. You'll be the first person to receive it. See you in the next free videos. Bye for now.